Ever wondered why some AI models learn faster or perform better than others? It's not just about having more data or bigger networks, it's about how they align with the patterns in the data. Today, we're diving into a groundbreaking study that reveals how learning rates, those tiny numbers that control how models adjust during training, can dramatically shape how neural networks perceive the world. Let's break it down. Picture this: you're training a model to recognize cats in photos. At first, it's clueless. But as it learns, it starts picking up on key features: fluffy fur, whiskers, the shape of ears. Here's the twist. Researchers discovered that the rate at which the model learns, the learning rate, affects how precisely it locks onto these features. This is where things get fascinating. The study focuses on kernel target alignment, KTA, a measure of how well a model's internal map of the data matches the actual labels it's trying to predict. Think of KTA like a compass. The higher the alignment, the more accurately the model points toward the right patterns. And here's the kicker. When models use larger learning rates, this alignment surges, but not randomly. It aligns with the most fundamental patterns in the data, like the big picture shape of a cat, rather than tiny details. To understand why, let's break it down. Neural networks have hidden mechanisms called eigenvectors, which highlight the most sensitive directions in the data. Normally, these sensors might wander, picking up on noise or irrelevant details. But when you crank up the learning rate, something magical happens. The sensors lock onto the most important patterns, the ones that truly define a cat, a movie review, or whatever the model is learning. It's like training a dog with a more enticing reward, focusing intensely on the goal, ignoring distractions. The researchers tested this hypothesis using models like BERT for text and ResNet for images, analyzing datasets like IMDb reviews and CIFAR10 photos. They found that higher learning rates caused KTA to spike, but only during a specific phase of training, when the model was balancing on the edge of stability. This is a sweet spot where the model isn't too shaky, which causes errors, nor too slow, which stalls learning. It's like a tightrope walker finding their rhythm. But why does this matter? Understanding how learning rates shape alignment could revolutionize AI training. Instead of just chasing speed, we might optimize for precision, making models focus on the right features from the start. This study is a step toward building smarter, more efficient AI that doesn't just memorize data, but truly understands it. So next time you see an AI acing a task, remember, it's not just about brute force. It's about fine-tuning an invisible map of sensitivity, dancing on the edge of stability to find the best path forward. Thanks for watching, stay curious, and we'll see you in the next deep dive.